Hi everyone. Welcome back. And okay, so while we maybe wait for more people to join in, I'm hoping that at least a few more people would join in. But anyway, so we'll not really wait. So if you have any questions from the last class, you tried to do the assignment. I saw that. Well, it didn't really went well for most of you. So if you want me to revise that, we could revise the stuffs, and or I could move ahead with the XML thing, and or we could revise and do away with the XML altogether. That's completely up to you. But if there are questions, and if there are specific things that you would want me to do this, so yeah, there are. I know that. Okay, so what is the part that needs to be revised? So I had some expectations from the people who are doing the intermediate one, and probably I was not very articulate and not very clear in saying what kind of people we expect in this session. So, we were not expecting people who are still kind of working with or struggling with Python. Okay, so we were expecting people who are confident with their Python, who have actually worked in Python, who have written some kind of uh, program, some kind of an application in Python. It's not meant to be an introductory track. It's not meant to be an introductory class. uh, I was not hoping to sit with you and debug your program. So I was expecting that you would know how to debug the program. My uh, understanding for, or my idea for this track, intermediate track, was that, so you see, Salman, that's the kind of things that I'm talking about. So I'm not expected to, solve your errors. It's not a fundamental course where I would solve your errors. My job here is to only introduce you to some of the libraries and to give you a basic overview. So you should already be very, very comfortable with Python. You should already be able to do stuff in Python. Right. So, if you are facing, so Salman, I see that slash t is wrongly written. So I really don't want to spend time on that kind of stuff. I would expect all of you to have a good idea of Python. It's not that you are still struggling. You are struggling with variables. You're not able to debug your program. Then you attend the basic track, and that is what the basic track is meant to be. That's why, and I see that there is a huge number of people in the basic track, and that's fine. And this is a smallish group, so we were looking to build upon so the things, you might be working with certain kinds of things, and you are writing programs, you're using Python in certain kinds of work, certain kinds of application, and certain kinds of already, so you have worked with certain kinds of things, or uh, at least you have a good idea of one programming language, so that you know how to debug, and then you have an idea of the, so even if you have not written a lot in Python, you have actually written a lot of programs in some language, and you have an idea of Pythonic structure, so structure of Python, right? So I mean, I would not really want to spend time with that. So, the question that I was trying to ask is, what part of the uh, CSV and JSON library that you didn't understand? So, I will not go through the program that I wrote line by line. So the CSV library says very simply that uh, you could I mean, it allows you, it doesn't say anything, so it allows you to read uh, a CSV formatted file, uh, and in a principled way you could access that file as rows and columns, and then you do whatever you do with the data. So if you have problem in understanding that part, which I am guessing it there shouldn't be, uh, but then explaining other parts of my program, those they don't even use any specific library. It's a very very simple program. It's a very simple thing that we are doing, putting we are just putting the stuffs in the dictionary. I was the first task was I mean it was if you have done any bit of programming, you'd probably you'd know that things like putting things in the dictionary and then making a frequency. So these are the kind of stuffs that we kind of do on a daily basis. That's what I would expect, at least from the participants. But if you are not comfortable with Python, and if you are not comfortable with programming languages in general, if you are not confident about it, if you are not sure about it, please let me know. And my suggestion would be that you be in the basic track. So I mean, we had a chat, and I was not expecting say so I had expectation that there would be five odd people in this group. So it's good that there are more people. I like that. But I really don't want to go through the same stuffs that uh, yeah. So I need to know what is the delimiter in CSV. Delimit you Salman, exactly how what's the question? So what is the delimiter in the file that I have shared, or in general, what do we mean by delimiter?
Sir, I wanted to ask ki, like the files we were doing. So it was written it's CSV file, right?
Also, box brackets in JSON.
Hello,
Okay, box brackets are basically list. So inside those
can you hear
box
me?
brackets, you could put up one or more than one um, objects. So basically, box brackets represent arrays, and you could put objects in the sense that you could put one or more elements with curly braces, and uh, inside those curly braces you will have a very similar thing that you have in a Python dictionary. So key value pairs. Yeah, so yeah, that's the one, and that's why there was a different file for the lab session, because you will always need to take a look at your file, your data in some way. So if you don't look at your data, it will become almost impossible to process it. So you need to have some idea of your data. It doesn't matter if other people, the person who has given you the data, they are telling you or not. So it's always a good practice to have a look at your data, and then think about how to process that. Unless you have an idea about your data, you just cannot go about processing it. So that will become very difficult to process the stuffs. So um let's what I'll do is so I just said all of this because I just wanted to make sure that you are actually very very comfortable with writing programs, you know so I somehow I got an impression that at least some of you are not, and that is not that if it's so, then it will become very difficult to uh, understand the kind of things that we'll be talking about. So and I really don't want you to be spending time on something which is not yielding results. Okay, So that's all I had to say. If it's just the case that you are comfortable, but there are times when we actually uh, when we are just a little bit rusty, that's okay, that's fine. uh, that happens with all of us. Also, reading other people's code is also sometime, or most of the times, actually really difficult also, because it's not a particularly well written code. That's what I said yesterday as well. So I quickly you know kind of concocted this whole thing. In fact, I was while when I started writing, I had not uh, really planned that I will end up writing this. So so there could be inconsistencies in the code, and there could be stuff that, but yeah, soon after I designing this, I thought that this could be a good way of presenting this, that we go up to the level of prediction. So that's essentially what most of the times we end up doing with the data, not all the time. So yes, you could be doing a lot of different things, but everything that comes in between, so things like arranging things in a list or in a dictionary, so those are the kinds of things that uh, uh, most of the times people will do. And there are better ways of doing it. So the instead of so yes, list and dictionaries are still the Python native data structures, right? I think from tomorrow onwards there are a few classes on pandas. So pandas is, and um, we were in fact planning to keep it more rigorous, and we also wanted to do numpy and uh, scipy, but since it's online, we are not giving a lot of time to the lectures, so we reduced that, and we have just kept pandas. So pandas is, it gives you one of the uh, it has a data structure, defines a data structure called data frame. And we'll talk about how to use data frame. So more appropriately, Ganesh will talk about how to do that. So in this class, what I wanted to do was, in these couple of classes, is just to introduce you to those different file formats and how to process those file formats, right? So I think the problem doesn't lie uh, in this part, if I'm not uh, uh, wrong. So this is the part that I wanted to focus on. I guess, should I, is it visible, or should I increase the size of the font or something? You please unmute and tell me. I am not looking at the chat. Is it okay, the font size?
Yeah, it's okay. It's okay, sir.
Alright, it seems that probably my speaker is also not working. Anyway, so I'll just try and give me a second. I could see the chat from here. Right, I'll just open this. Just give me a second. I'm just trying to keep. Okay, Rajesha, yes. Uh, you could actually continue if you are comfortable. So you need to be comfortable in one language, very comfortable in one language, and aware of the structure of Python, so syntax of Python, not right. So and that will be good enough, because you have an idea of how uh, what are the programming constructs and things like that, comfortable using that, debugging the program and stuff like that. And if you are you have an idea of the syntax of Python. So if you, and it's not a very difficult syntax to pick up actually. So we keep on saying that Python is one of the easiest languages to learn. It's one of the easiest if you are first time learner. It's actually cakewalk if you have written programs in other programming languages. Uh, so okay, so now if this is the part that we were focusing on for the CSV file, that you read it through an iterator, and that iterator is constructed uh, by your reader, csv.reader module, and uh, it basically converts the file into the CSV file into an iterator, which you could access uh, row by row, and then you could access each element of the uh, row, right? Okay, so um, I think that part should be clear. The lab exercise that you were asked to do was to, yeah. So you see, here what we are doing is adding the words, all the words to the dictionary. Now, for there are several ways of doing what I have asked you to do. So one way is to, once these all these words are added, then you go through each of the labels again, and for each of those labels, you actually convert that list into a counter object. Yeah. So do a loop through each of the key value pair, change the value into a counter object that will have the count of each of the words in that. So if you want, I could give a demo of how that could be done. So or the other way is to completely rewrite this instead of doing words here, extending it with words here. So let me show you. So yeah, so you could directly actually keep on adding the frequency of each word in that. So instead of doing a list here, which you are doing, so instead of adding these words here, you actually write the frequency of each word and do that. So you could try that out, the other method from the scratch, but if you already have this, then you could actually go through each level in, actually could iterate through label and word list together. And the best way of doing this is to have a new dictionary where you could actually store that, right? So word list frequency could be done using counter of word list, as simple as that. And then you simply label is equal to word list frequency. That's it, you're done. So that's your that will create you know uh, a dictionary, so basically a map where each label is mapped to uh, a dictionary of count of each word. So this is essentially so counter objects are essentially dictionary. If you want, you could convert that to a dictionary explicitly as well using the dict function. You don't need to, counter is fine. And so this will actually have all the uh, you could try it out in your system and try and run it. I'm not running it, and don't run the whole of it, run a part of it, so you could have a look at this counter object and see that what kind of stuffs are stored there. So this is something like this, but instead of these labels it will have all the words that have occurred in your uh, data set with their frequency, right? So and that is what you're storing with level. So now for each level you have actually a frequency word list. Okay, so that was the first exercise, and the same, exactly same code will go into the JSON as well. So in fact this exercise was not even testing your understanding of CSV, how to put it, so CSV library, right? So and this one is actually also not doing that. So now I think I leave this to you for now, so you could modify this code so as to predict you know so so at this point of time we are just checking if the word is in that dictionary or not. uh, you could actually, I mean, it's a very simple change that you have to do. It's not uh, so I'll do this as well. So you get your that thing, and then you get the frequency of the word inside that. Now there is one little thing that you'll have to do here though, is this is not needed anymore. So that was this just checks if the word is in there, then it will return a zero and you convert that to zero, so the count will not be increased in that case. If the word doesn't exist, if the word exists in this uh, um, list, right? So in the list of the words of not category, then you will it will return a true, and you do pass it to an int function that will return basically one, so that one count will be added to the count of not words, right? So that is what we were essentially doing. We were counting how many words in the sentence uh, occurs in the HOF, how many words occur in the not. So if a particular word occur in both HOF and not, then it will be counted one in both, and that is kind of nullifying. Now finally what you're checking, if the number of unique words, so out of the total words in the given sentence, are there words that are only in HOF that are greater, and the number of such words is greater than the words that are only in not, right? So that's what you are essentially checking here. So now that you have frequency, so we'll just use frequency of each word, uh, frequency of occurrence, and you could do a lot of things here. You could do a lot of sophisticated things here actually, for making the prediction system better. But my point was not to make the prediction system better, it was just to play around a bit with it. And you will need to put an if condition here actually, so in some way you'll have to check. uh, so the best is don't use this. uh, so I have forgotten if this will work with the counter object or not, but I believe it will. So just check if this works with the counter object or not. If it doesn't, uh, then uh, either you convert that the counter object to dictionary before adding here, or you could actually use an if condition here to check if the word is in that, then only you do that. So this get essentially does the same thing. I hope you know that if the word is in that dictionary, it will give you the value for that word, which is the frequency in this case for that word. If that word is not there, it returns a default zero value, which means the frequency of that word in that category is zero. Okay, so it's as simple as that, and it adds up and then it does the same stuff. Okay, so that was the second thing that you were supposed to do. uh, and what was the third thing? You were supposed to assign a random id, and I think I'll not do this one. So you assign a random ID to each sentence while writing to the file. So along with the sentence level, you generate a random number. I hope that you know how to generate random number in Python. Generate that random number in between 1 to 1000, 1 to 10,000, or anything between 10,000 to 99,999, anything like that. Any random number that you want to generate, and assign that to this. You will also have to, if you want to do it really well, you will also have to put all of those random numbers in the one way of doing that is to generate uh, a list of random numbers. So depending on how many elements are actually there to be written, based on that you could generate as many random numbers, and those will be unique random numbers generate if you generate it once, all at once, and then you could use each of those and assign it here and do things like that. Also, I wanted you to change the delimiter, so that was simple. In fact, I did this yesterday as well. So the all the three uh, tasks, as you see, it would not it should not have taken a lot of time. Even if we assume that, yeah, it's little difficult to read and understand the code written by somebody else. I think I'd given some explanation yesterday, and I'm hoping that this explanation made some sense. And you could make similar changes in the JSON thing as well, and you just have to see how to. So the only place where actually CSV library comes into picture is probably here, where you are trying to write some additional things to the CSV file in addition to what has already been written. Yeah, so is that making sense, or is it still very, very confusing? They are so, I think that everyone has gone to sleep. So they didn't even, I mean, all right. So do I need to repeat the same thing with the JSON file, or anything else in the JSON file that is not making sense? Then I will try and repeat that. No, okay. So no, I don't think so. Okay, it's all right. So yeah, of course you need to give it a try once more. Try to read. I was hoping that you will have some practice of reading the code as well. Uh, so writing a code and reading a code is slightly different set of skills, and probably I could have given a little more documentation. So what I'll do is, if I get time, I'll add bits and pieces of documentation after the class today in this code, the broader documentation, what exactly they are doing. So I only actually, wrote description for those parts where which is new and which was for the library anyway. So I've been very lazy actually in doing this. Sorry about that. I'll actually make it a little more explicit, the documentation part. All right, so I guess we will start with XML, and probably just a little bit of you had a look at an XML file the other day, and uh, so and if you are familiar with HTML file, you would know that uh, it's very similar to HTML. So HTML is also a markup language. So XML refers to an to extensible markup language, and uh, it remains actually in fact it's gaining in popularity. It's one of the most popular file representation format on the web. So you see, JSON is used for interchange. It's a lighter format. It's also a cleaner format. But XML also remains kind of one of the most popular stuffs out on the web, because for various reasons. JSON gives you a structure. That's all right. That's okay. And it gives you readability. And XML also gives you the structure. But the real strength of XML, it lies in the fact that there are a huge number of XML technologies that gives you a huge number of advantages in different terms. So you could actually modify the XML file and visualize. So it in different uh, ways, different formats. You could actually choose which elements to display in what way, and so on so forth. You could actually make changes in the DOM structure itself on the fly, so you without changing the document itself. You could actually uh, so there you could on the fly, in the sense that you read the document, then you make certain changes to its DOM structure, and then you show it to the user on the web. So it's not there in your document, but there are things that you could actually show while showing. You don't need to save all of that in your document. So it gives you huge advantages in those terms. You really don't need to create new files and stuff like that. uh, Querying and modifying the data. So xquery uh, is something which you could do. So it basically transforms your XML file into some kind of a database. And so you could query. FLAR is a very popular acronym for querying XML files. So if you have worked with XML, you would know that it's kind of a gold mine. XML, they could be your database, they could be your HTML, and they could also be your JSON, so all at the same time. So you just create one XML file, and users could actually read it. It's structured format, humans could read it. It's human readable, very much human readable. And then you could use you could use the same file for so you could use CSS with XML. If you are aware of CSS, uh, XML has its own style sheet. So you could use style sheet as well. And I forgot the name of the XML style. If some of you have worked, then you'd probably know the XML XSLT. Yeah, XML styles something something. So I also forgot the it's been almost 6 months since I worked last on that. So XSLT files, and you could actually create your own style sheets and to show the same file on the web, on your website. And the same file you could query it as a database. So uh, it's like the full package in itself. And that's probably the reason. And there is an increasing support for increasing number of support for XML coming up. There are new technologies that are being developed around XML. So uh, it's kind of has become an essential part of uh, the semantic web technology. Is not essential, but a very important part of that. So a lot of your RDF data is actually represent. So RDF data could be serialized in several formats, and XML is not the current favorite. So Turtle and a couple of other formats are used for serializing the RDF data, but XML remains so one of the choices for representing, and a huge number of projects actually use RDF XML for representing their RDF data. So that makes it actually an excellent language to learn in itself, the XML, and to work with XML file, uh, ma- online, offline, everywhere, every way. So it's kind of my favorite file format. I have used XML for the last almost 10 years now. So since my PhD, I'm using XML files, and and it has proved to be very very uh, you know uh, so how do I put it? So it kind of gives you everything that you need at certain point of time with to do with your data. So you don't even need to you don't even need a language like Python for querying it, for searching through your XML file. You could use xquery for searching through your XML files directly on your terminal without going through all of this code. No, you could of course use Python or any other programming language as well to query your XML file. So also it has a big advantage over the traditional relational databases, because you don't have to install additional stuffs, and you could actually open it and see it. So somehow I find it very comforting when I could click and open the file, or I could open it even in a terminal, so I could open and see it directly. So how things are there, how things are being saved. With Probably I've never used RDBMS, so I'm not that comfortable with RDBMS uh, in that sense. But it's still, logging into a database management. If you have to quickly see something, if you really want to check something, or if you want to show something to somebody, and you could quickly open your XML and show it right there. With an RDBMS, you really have to go through the whole process, loading the database, loading the table, and then thinking about what kind of table you have to build and show, and things like that. It's not uh, it's not really a file. So RDBMS is an excellent piece of technology, but it's not really a file system. So XML somehow gives you a database advantages in a file system. So nothing like that. Now XML with Python is actually even better, because uh, so uh, it's if you have worked with XML on in other programming languages, you will see that Python library makes it so much easier, even though it's not as straightforward as a JSON or a XML or a CSV library. But it's still, I mean, I used to work with XML in Java. It and, so there is no comparison, so to say, in processing and reading and modifying XML in Python. So it's just a few lines of code, and you are actually working with uh, some kind of a Python dictionary here. Okay, so this is the library. The name of the library, as usual, is XML, and we'll basically be using this module called elementary. We would import that library in XML. The We have multiple files of XML. So if you will look in the same folder that I shared yesterday, you will now have these two new folders. One is XML dataset and one is XML lab. The two data sets that I've shared, these are again these are not my data sets, but both of these are event annotated data sets yet again. So I think one is Bangla, one is Tamil. Which one is which I've forgotten. Both are Indian languages, both are in Unicode, and they are annotated with whether the text is represents event. So the yesterday the JSON data that we used, that only had 01 marking, so whether it was showing event or not. So this is a slightly different kind of data set, where you have this everything written in continuous paragraph. Maybe I'll try and open and show one file to you if that opens. Yeah. So if you will, let me increase the font a little bit. What happened? I hope that's kind of visible. So this is the Bangla data set. So you really don't need to know how to read this to process the file. So you'll see that it has these IDs and other stuffs are there. The text itself is there. You look that if you look at it, you'll see that each word is actually tagged with a W tag, right? And for each paragraph which starts with P, you have this thing marked. If it's an event, it will mark, whether it's a man-made event or if it's a natural event, and sorry, and then also type of the event, so subtype of the event. So in this case, it's a cold wave here. So then you'll see, if you look further in the file, you'll see that there is a natural event here which says if the type is blizzard, right? So then of course there are lots of, so it's a very richly annotated event data. This was released this year in fire 2020, one of the tasks which was on event detection. There were a couple of institutions involved in this, probably if I'm not wrong, probably IIT Kharagpur and a couple of other institutions. They uh, made this data set available and in multiple languages, multiple Indian. These are newspaper data sets that are annotated with events, so and kinds of different events. So it's a nice, richly annotated data set, as you could see, and there are lots of things that you could do with it. And it required and that it be done in XML, because otherwise, for some kind of data annotation, you have standard formats such as Cornell or Cornell U. For event, sort of Cornell or Cornell U doesn't kind of work, because you have different so different spans of text which is annotated, which needs to be annotated with different kinds of information. And so that span annotation becomes except when you are doing a dependency or a phrase relation annotation, then you could use Cornell U format. But for this these kind of annotations, XML is a good format to choose. It allows you to give all kinds of information, and you could see that which we won't get into the details of what this has annotated, but broadly uh, we would try to read uh, whether a specific paragraph has some event in that or not. And if there is event, then we would try to get the event subtype from that. All right. We'll try to use that for building a similar system that we did yesterday. So अरे यार, yeah, okay. So the point, how do we read this? The data set might look very daunting in the first um, look, because of several reasons. It's in a language which you probably don't know. It uses an annotation scheme which you are not familiar with, and it's in a format which you are not used to looking at. Also, it's not actually formatted in a human readable way. So that's generally so XML that I showed the other day, that was kind of formatted in a human readable way, but this one is not formatted in a human read. So it might look a little difficult, but I've tried to make things easier for you. The all the information in this set of code, so I'll go through it one by one. And this is, as I said, it's a more involved way of getting the data out of XML. So basically we start here. So this is just traversing through each and every file uh, in the directory. Once you get the file, you'll see that right from here, line number 5, we are actually not not reading the file in the usual Python way. So we are parsing it as element tree. So this is basically it will make your give you some kind of a tree representation which you could traverse through, right? So as you traverse through a tree, some kind of a or if you have done graphs, then you would know that you know how to move through trees or graphs and things like that. So uh, uh, you just give the path to this, and it parses and gives you the tree of the document, right? Now the first step is always to get the root. So unless and until you have the root, you cannot move ahead in the tree. So you start with the root, and there are several different ways of accessing different elements in the XML document that the library gives you. So, and it depends a lot on the uh, iterators here as well. So you know that there are multiple p elements, and the p elements are the ones which contain the text. So and this you will get to know, you will get to figure out for any data set by looking at the file itself, or if you have the schema or things like that. So if you have XML schema, that makes things much easier. You could actually implement all of this just by just looking at the schema. But even then, it's always makes things easier if you look at the document itself. So basically we are saying that we iterate through each of the p elements, and inside that p element you are getting all of these different sub elements. So you iterate through each of those sub elements inside the p element, and you get the tag for that sub element. So you see, this is not some kind of a generic code, and that's what happens with text processing most of the time. So you will have to write code specific to the file format that you have. So even with the CSVs and JSONs, so you don't know which column in the CSV will have the text, and which column will have the the annotations, and which one will have some other information. So I actually didn't share the other file that I was planning to share. That was collected from Twitter, and that actually had uh, quite a different structure, CSV structure. So everywhere, so you have to specify the column names, from where to get the data, from where to get the text and stuff like that. So that goes here as well. You took a look at the file, you saw that okay, there is this structure to the file. There is p, inside p there are sub elements, and inside that sub element the specific kind of element which has the tag w, that contains my text, right? So in order to get that text, that is how you move through the tree. You go to p, then you go to each element in the p. You get the tag for each element. You check if the tag is w or not. If it's w, then you know that inside that there lies your the text of the file. So you get the element dot text, and that's it. If you have got a w there, right? So that means that there is no event related information in that within that tag. So you get the text, right? And the level is what you assign yourself. So just for the sake of convenience. So no event is not marked in the file is something which we are using for being able to process it here. All right, now if the tag is not w, right, so the tag inside the p is not w, then it could be some other tag inside that you will have w. So and if you want you could have a look at, I'll have to search for those examples. So and I'm just able to do this because uh, I just recently processed this one, so I remember, and that's why the code is also written. So you could search for this, and you could have a look at it. It will take some effort in figuring out the exact structure of the document, and every document is a different kind of document. However, the other lab document that I've shared is from the same set of documents, so that also will have the same structure, and this will work for that as well. However, I would be sharing another XML document which will have a different structure, and you could use that for practicing and writing code from the scratch for that. Okay, so now so we saw that one way of getting the elements is to iterate through each of those elements, so using the for loop. The b- so This is what using the iter function. Now there is another function called find all. Find all, so iter function will go to the next sub element, only to up to the next level in the XML structure. The find all will actually go uh, through all of the sub elements, and wherever it finds w, it will fetch that, right? So it will fetch that w, and again inside that w tag you get the text and stuff like that. Now for that uh, uh, so the let me come back to this. So the tag, the main tag, so I'll just show you once more. So you see there are lots of places where w is uh, directly there, but whenever there is an element, w is actually preceded by some kind of tag, some kind of event tag, right? So this is what w is preceded by. So here you will see that w is preceded by this much of information about the event, if there is an event. If there is no event, you see that here w is not preceded by anything, right? So however, there is something related to event here, so w is preceded by this tag. So the idea is that if you directly get w, that means that there is text, there is no event there. If you don't directly get w and you get some other element, that means every element that precedes it has some information about the event that is happening, and then you have the text, of course, there. So that's what we're trying to implement here. So if the element that you find is not w, something else, then you look whether its tag is natural event or man-made event. If yes, then I'm putting label here as event, but you could actually take the tag itself as the one. So so essentially what I'm doing here is that I'm combining the two together, natural event and man-made event, and calling both of them event. Just trying to make a binary classification problem, event no event thing. But you could originally it was a three class classification problem. So anyway, but now you could also you'll see that if it's a natural event that we saw, then it has an or if it's a man-made event, then also in that case it has a type uh, attribute. So this is called both of these are the attributes of the element natural event, and it's again a key value pair. So you have a name for that attribute, and then there is a value for that attribute. So you have an id, but you also have a type, right? So type of the natural event. So if you have event there, then we go ahead and get the subtype of that event. Okay. if the tag is not natural event, so you or man-made event, so you see that there are these associated event link and after effects, so there are these different tags. If those tags are not there, that's not immediately relevant for us, that's not immediately useful for us, then we simply say that as usual that word is not representing any event there is, and since there is no event, the subtype is also no event, right? Now, through this, we actually managed to get all the text across. Uh, okay, so I think I did something. This was not actually needed to be done because you don't need to split this. Oh, so this was done because the some of the files are actually a little noisy. So there are some cases where there are actually multiple words inside the single W tag. So in order to handle that, this was just done, the split stuff, so that if there is one word, then it's fine, and it will return actually one word. If there are multiple words, then it will divide those multiple words and then return each of those words in a list, which you could then add. So we ended up getting the same data structure that we were actually getting for the CSV and JSON file out of the uh, XML file, which looks and which actually is very, very different from the other CSV and JSON files that we saw. Right, so the data set is quite different, and the structure of the data set is also quite different. But so uh, this is a good practice in text processing and probably in general in programming, that you have for this set of experiments, uh, you always try and bring your data set into a standard format, a standard in the sense of format from where uh, all your systems, all your functions and all your programs actually depend on your data being in that kind of data structure. So all my code here and all my prediction stuff here, it depends on the fact that you have a map of each label mapped to a list of words that occur in that label, right? So that's the structure that I need for my this system prediction system to work. And the whole goal of doing of processing these files is to bring uh, your data, which could be in n number of formats, which could be in n number of different formats. So you bring that all of those n number of different formats to this one structure, which you are ultimately going to use for your experiments, or for your work from then on, right? So that's what the whole exercise of this is. Yeah, this whole exercise ultimately ends in bringing your data to this map, right? Now, if you have this map, and I showed you that the lab exercise is actually exactly same, so you modify this to get a uh, uh, dictionary of count of each word. And now there is a little bit of complexity as well here. So we have the subtype information, right? So you also need to include or if you want to define a new map, that's fine, or if you want to do it in this itself, that's also fine, that's up to you how do you want to do it. But you also create this map for each of the subtypes as well, right? So we are already reading the subtype, you could rely on this uh, and rely on this code that it will get you the subtypes. If it doesn't, then try and debug by looking at the files and your data and try and debug this. So that might also be a good exercise, but that's not intentional if that happens. So I believe that this code will work on the dataset that I've shared, and it will get you the subtypes. The only thing that you have to do is for each of these subtypes, so you'll have to keep a track, a little bit of track about uh, the text and stuff like that, and when to add those subtypes, and little bit of bookkeeping you will have to do in order to get the frequency dictionary for each subtype as well. So because there are lots of times when you will not get a subtype, right? So subtype is no event. And actually there's little bug here. I have not defined subtype which needed to be defined. So here we should have a subtype. I'll just try and make it easier for you. Going by the yesterday's experience, uh, I'm making things easier. So yeah, now you have the subtype everywhere, and you could simply make a new map of the subtype and also do a frequency of each of the words in each of the event type as well as the subtype, right? Now this part of the code is very similar, and this works with the list of words but not the frequency uh, list of words. So frequency of each of the words in that list. So again the you could no, in fact this is becomes so uh, you know so unidirectional that you actually have to do that. But in addition to that, now you also have to predict the subtype. Right? So you've created a subtype map here. In this step, along with the event type, so event type is a basically event no event. You could actually do it three class as well यहाँ पे, as I said earlier as well. So natural event, man-made event, and no event. You could, instead of putting a label is equal to event, if you simply replace this with label is equal to e tag, that will give you the three class thing. I'm still not putting it here, but if you want you could try with that as well, and you will have to make certain changes here. You will have to actually that's it, you will have to make certain changes here. So event no event will actually be man-made event, natural event, and no event. And then of course for subtypes, so the question is how will you know? Here you know the name of the labels, but for subtypes there is, you don't have a list. So you could actually print each of the keys of this map, the subtype map that you have, and you will get the name of your subtype from that list of keys in the dictionary. And you could modify this code to predict the subtype as well. So that's the second task. And the third task is of course then you are storing. So remember that here we are storing everything in a map. We are creating a log of the sentences that were inputted by the user and the predictions that were made by your system. So you're putting a log of that. We are keeping a log of that. So in here, once the user exits the program, essentially you write that log to another XML file. So writing XML is very similar to reading XML. Uh, so basically you create that tree. So there at that point of time you were uh, traversing through the element tree. At this in this case you are generating that tree. So you start with a sub element, and you have these different so you start with the root sub element, and this is the name of the element. So the second argument in this function is the name of the uh, element, which is document. So that's your document. That's the root is called document. You could call it something else. You could call it log, or you could call it history, something that you are more comfortable with or that you find better. So you could experiment with that and see what kind of document that is generating. And then for each phrase essentially sentence, and for each event that was predicted, uh, you create a sub element of that event. So this structure is very similar to the structure that is there in the original document. So that's by design. It's kind of, these are the kinds of things that when somebody is using your system, you are actually also getting back some data from that, right? So you are basically storing that data. And we could argue a lot on the ethics of doing this, but uh, it's one way that you could actually get more data and improve your system, and that's most of the uh, so the big companies are doing. That's so the more you use, the more data you give. In fact, we are not storing any other kind of data. We are just storing the sentences and the phrases, but of course the big companies store your each and every movement, starting from your click and the deletes. So the you typed a character, you deleted that, and all of those events are actually logged in the system. So we are not doing it at that level, but yeah, this explode this to a much bigger level, and you get what uh, you get the privacy issues that we talk about today. Anyway, so basically we save it in the same format, so that it could be, reused. And so in some way, you could probably, if the predictions are, you could have somebody to go through the predictions once and maybe correct those predictions, and you get more data quickly. And you don't need to generate the text themselves. The text is given by your users, the users of your system, and you use that to improve the system further. So essentially, you are writing it in a very similar format to that. So event will be your sub element that you are writing to. Inside that you will have the phrase itself. So you're putting text of the event is the phrase dot you have the phrase that you have, right? So that's the text of the event, and this is the sub element of the event. So, and of course we are not using the w tag here, so it's not exactly the same. But if you want, you could actually split your text and put each of them under a w tag. um, that's an optional exercise that you could try out. Once everything is done, then you generate the tree, and you basically do a write operation. This write operation is also provided by the elementary library. So this basically writes your XML tree uh, uh, into, it basically serializes that into a XML file, the elementary, right? So that's it. And you could have as many sub elements and elements, and then their sub elements. So you see that um, uh, the, these are actually the uh, elements, and sub elements are the, you could actually have sub elements within the event as well. So instead of et dot sub element, you could have event dot sub element, and that will be a sub element of the event tag that you have here. And that is where your w's will go if you want to use the w's. And you could then have text for that. And so that's how the tree is created. So you have to decide which elements will have what kind of sub elements, and those sub elements will keep on uh, adding as per your requirements. So is a simple example of how to create an XML file and how to read an XML file. And if you have at all worked with XML earlier, you will realize that this is a much cleaner and neater way of doing things, of accessing XML and writing XML. Much probably much not uh, uh, hugely cleaner than probably the other libraries that are, but still it's some I find it's actually a uh, good clean way of creating XML. So XML generation also has its own sets of restrictions and stuff. Like there's certain characters that cannot go in the XML text, and there are certain ways this could be done. So writing that as a string, as a normal file, creating an element and then closing an element, that's a very time taking task. Also it may not take care of all those conditions. It may actually result in an invalid XML document. But the library takes care of all of those things, and it creates a valid XML file. Also, it will read XML files properly only when it is a well formed valid XML. So if there is some issues in your XML file, the library will throw up an error. Okay, so that also indicates that things needs to be changed with the files. Okay, so the lab for this part is again the same. You assign a random ID to each sentence while you are writing. Now you could actually uh, assign the id as an attribute. I haven't written here how, so you could just go on the web and have a look at the documentation of elementary and see how do you add attribute to an element using this element tree module. You could do that, and uh, the element name could be doc id, for which the attribute will be id, or you could directly add an id to this element document, right? So also since you're predicting the sub type of the event, and we are not writing that subtype of the event, so subtype will also be written as an attribute. We saw that the event type is an element, but so the subtype of that, so whether it's a man-made or natural event, that is your element. But whether it's a blizzard or whether it's a cyclone, if it's a natural event, that is the subtype of that. So you again that is the attribute of that element. So you again, for writing subtype, you need to actually put that in the attribute. So this is a bit of a task to go and look into the documentation of elementary and figure out how to do the attribute thing. Okay, so that's it for today. I hope uh, it was not completely uh, blank, but if you have questions and if you have things that you want me to go over again, please feel free to ask. So it seems that everyone has either ran away or are asleep. Okay, no questions. In that case, we may finish the session actually. And okay, there is an announcement for the lab session. Since I have seen that only 2 or 3 people turn up for the lab session in the intermediate track, I am merging the lab session of the 2 tracks. Okay, so you will get an email if you're not attending the basic track. I will send an email to the group now. You check in 10 minutes or so, and you use that link for joining the lab session. Okay, not this link. And um, so I may not be there today for the entire session, but there will be other people who would be able to help you out in this. Okay. No, just don't join here. We will not be here. This meeting will not uh, be started again. So please join in the basic one. I'll share the link in the group. Okay. Also, so probably I should say this. It might just be the case that these first 2 classes are more sort of complex than the next classes that you will have, partly because you are probably not familiar with the file formats that I'm talking about. Also probably because I sort of you know uh, so my assumption was probably something else, and I probably went a little overboard with this, but I will try and simplify things from next class onwards. So hopefully those classes will be more accessible than today's. I hope that. Yeah, Rupkatha, please unmute and you could speak. Yeah.
Okay, sir. So I was uploading the file from my system, and I was not really mounting it from the drive. So every time I'm uploading something on Collab, um,
So I'm so
so
sorry. I think my probably it has got something to do with my speaker.
should I write it
Give me
down?
a second. Yeah, could you repeat the
Hello.
yeah.
Yes, so my question was that I am uploading the file from my system in Collab every time and not really mounting the drive and all because I found this was easier. And the only problem I'm facing is whenever I am uh, like logging out or signing out, it just disappears, and every time I have to upload it, and that takes a lot of time. Is there a way to save it permanently, or do I have to keep doing it?
Yeah. So I think this there was a question regarding this yesterday as well. So yes, that will disappear if you upload it, or if any new file is generated by your code, and that's a temporary hard disk that is made available by Collab for your use, for your immediate use. It is not meant for storage. So that's why the files will not get stored if you are uploading it directly on Collab, or if anything that is created directly on Collab. So it will be accessible only for that session. So once you log out of the session, it will go. So the for if you want to avoid uploading it again and again, that's
Hmm.
where the drive comes into picture. So you upload it on drive, you mount the drive, you use it. So you don't have to upload the file again and again. Okay.
Okay, okay. Thank you, sir.
Where do these files, new files, for example, the JSON or CSV file that we created yesterday, get stored?
So I don't know what path did you give for
As in,
save.
uh, in this very session, the log.xml file. So
Yeah, did so you won't be able to see my file, right? So actually this log.xml file, I am if you look at the screen, so you'll see that I'm actually joining this with our dir, and if you look at our dir, that's my drive uh, path. So it's inside this folder that it will be created. So it depends on you where you are.
so
So
they
that's why.
don't
Yeah.
get saved. They
Uh-huh.
don't disappear after the session like the files we upload.
If you are writing it in your drive, it won't disappear. If you
Okay,
are
okay,
not writing in your drive, it will still be created. The file will still be generated. It will be
okay,
saved. Just give me a minute. It will be saved in the the local
okay,
uh, cache there. So it's not actually a cache. It's a temporary space that is assigned to you by Collab. So it will be saved here, and it will go off as soon as you're logged out. Yeah.
okay, sir.
Okay. So just be a little careful about the paths. So what path you are giving, just try and understand where it will be saved, and it should be fine. It should work out fine. The collab file you shared for assignment is not working now. Salman, yes, I guess so. I am getting quite a lot of emails there, and I think I saw your assignment, right? So I think I did get your email, at least one email that I remember that I got. Yeah, so I mean, I said I remember one. I'm sure that if I got one, I would have got all three. So if there's something specific, then I would check for it again. So how many of you are actually facing problem with the collab file? So I've got a private message that um, the collab file is not working. The one that I'm showing now, and so what I'll do is maybe I'll share the link again. I'm just sharing it again, but it's the same link that I sent yesterday. It should work. Just give me a minute. It was not shared with everyone. Yeah. So see, don't expect the status to be updated immediately. It's not an automated thing. Okay, so and we are actually doing it manually. So it takes time, and also while the session is in progress, we are not doing that. So if you send us the some file in the morning and you expect that to be updated immediately, that won't be done. Yeah, so also last night, so I mean we were probably not awake, so if you send this is generally done at around in the evening at around 6 7 8 8ish. So if you send it by then, after the end of the lab session, it will be updated the same day. And yeah, so not around 9, so it will be done today. Okay, so don't worry about that a lot. We sent it for checking so that we don't miss out, or if there are emails that are not getting delivered for some reason, you are sending, we're not receiving for some reason, we could get those kind of issues worked out, sorted out. All right. So and this will be done. Your assignments, if you have submitted, they will not be lost. Don't worry about that. Okay. All right, so then I guess there are no more questions. Then we'll finish this session, and as usual, we'll see in an hour or so. But please remember that I'll be sending a different link for joining the lab session. Don't use this link for joining the lab session. Okay, so there will be joint lab session for both the tracks. All right, so I'll see you then. Hope I made some sense. Thank you very much for joining. I'll end the meeting now then.